Pay attention to that. Do everything you can to make these concepts stick. You need to be memorizing all sorts of stuff. This is the beginning of 6-3. I'm only doing half of it with you today. The other half will be for whenever we get back from snow days. But this is huge. Logarithms are huge, and logarithms, quite honestly, are difficult for a lot of kids. So here's the idea behind logarithms. We have a table here that's talking about seismic waves and the magnitude of the earthquake. And they tell you that this is the equation, y equals 10 to the x. So if we have a 2 here, this is obviously 10 squared, right? 3 is 10 cubed, and that's what this is, 10 to some power. 4 is 10 to the fourth. And they are asking you to estimate the magnitude an earthquake with an amplitude of 5,500 would have. These are not questions that are easy to answer. They're not. What you're doing is you're saying 10 to what power is 5,500? Now I can tell by looking at the table that it's between 3 and 4. And as strong as my mind is, I couldn't tell you what it is to the first decimal place. I'm saying I'm not saying I couldn't figure it out with a calculator. I'm saying I couldn't do it. And, you know, logarithms are pre-calculator stuff. People would go to a table and look at something that somebody's already done. People have always had ways of calculating things with assistants. But, you know, say you think it's like 3.5. You could be curious, you go to a calculator, you could type 10 to the 3.5. It's not. Maybe it's something like 3.7. Getting closer, right? My guess is 3.8 is going to be too high. So maybe it's halfway between 3.7 and 3.8. We're getting there. A little bit lower, though. But maybe you can see that even with technology, this is basically all we're doing is we're guessing and checking, right? Now, what a mathematician would do is they would say that a log base 10 of 5,500 is x. Now, because that's base 10, and the calculators actually have that built in, if it doesn't have it, it's understood. There's my answer, 3.74036 and so forth. And just because the calculator has a log button doesn't mean that you can just push buttons and be happy, because it doesn't work that way with logarithms. I'm sorry. They have log buttons. They have the natural log buttons as well, but you still have to know quite a bit of stuff. But that's the actual answer. And you can see I was getting there. Another few more minutes of wasting your time, and I would have got somewhere in that vicinity. All right. So this one is very similar to the last one. Solve 4x to the 80th accurate to the fourth decimal place. Now, here's what I know. I know that 4 cubed is 64, and I know that 4 to the fourth is 256. And I do understand logarithms, but you don't yet. But you need to understand what these things can save you ultimately. So let's try like 3.2156. They want 4 decimal places. That wasn't too bad. Let's just see what 3.2 is. Still too high. Too low. Too low. Too high. All right, so it's something about this. Let's try that. Too high. Getting there. Getting there. Too high. So that's even closer. So I can tell you that the answer to this is somewhere between these two right here. 4 to the 3.1609 and 4 to the 3.1610. You can still kind of solve questions like this by just guessing, checking, and plugging in numbers. Don't think that's anywhere, but that's how you might do it without logarithms. But that was kind of tedious. So if only there was another way of doing this. So the inverse of any equation written in the form b to the e equals a is as follows. A logarithm, base b, argument a equal to e. I teach log is Bae. Your goal is to spell B-A-E. And this is something that's on your form quizzes. It's been there the whole time for you to memorize or to ignore. This is the conversion formula. It is the easiest way to do it. You'll notice that B stands for base. E is your exponent. And A is your answer. Now over here, the B is still a base. This is your argument. That's what it is. It becomes the argument. And it's still the old exponent. But that's how you do the conversion. All right? So make sure you write this down, dedicate it to your memory. And we're going to do some rewriting. Write the logarithmic form of y equals 8 to the x. So I'm going to go through and I'm going to identify my parts. That is my base. The x is my exponent, which means this must be the answer. And this is what it kicks off. Log is Bae. I just have to take these pieces and plug it in right here. That's all I have to do. I will have a logarithm of base 8. Its argument is the old answer y, and it has to equal the old exponent x. You know, sit there and pause this and see if you can make some sense of what's going on. So on the second one, kind of the same idea. 3 is a base because bases have exponents, and this must be the answer. And then just plug into that. It is so simple. I will have a logarithm of base 3. I will have an argument of 81, and I will equal 4. And this, by the way, is true because 3 to the 4th is 81. All right, what is the exponential form of a log whose base is 10, whose argument is 1,000, and it equals 3? So this is always your base. This is your argument. And this would be E. All right, spell Bae. So the base is 10, the exponent is 3, and it equals 1,000. And by the way, this is true because 10 cubed is 1,000. When you first start writing these things, a lot of these you can just check for truth. Now, you know, going back to the one I was doing earlier, I could write this as a log base 4, argument 80 equal to x. And this is a lesson for another day, but in a calculator I type ln 80 over ln 4. That's what I do in a calculator. Play along, kids. See, there's my answer. 3.16096, which I was really close to. But just like that, I have it. All right. This is for you. I'm going to work these out here. It says, what is the value of each logarithmic expression? And what you're supposed to do is you're supposed to learn how to read these things and say, what is it asking? So these are asking things in words. They are. This is asking what power of 5 equals 125? That's what it's asking. And the answer to that is 3, because 5 to the third power is 3. All right, the second one, it says what power of 1/4, because 1/4 is the base, is equal to 16. Now, that's kind of a weird one to do. You have to have some knowledge of negative exponents. The actual answer to this is -2. That's the answer to this one. So because, I'll have to write this out. If I take 1/4 and I raise it to the -2nd power, I get to flip the fraction and make the exponent positive. And that is my 16. All right, example C. We have a base of 3, so it wants to know what power of 3 is equal to 0. And that's an easy one, because you guys know that anything with 0 power is 1. Which doesn't do you looking good, does it? A lot of kids will say, and this is wrong, I almost made the same mistake, I guess I'm tired. They'll say 3 to the 0 is 0. So the real question here is there an exponent that will turn a number into 0? Does that exist? You know, pause this, think about this. And the answer is there is no answer to that question. This is unanswerable. It literally does not exist. All right, the last one says what power of 2 is equal to 2 to the 8th? And this is an obvious one. The answer to this is 8. You just put 8 there and you have equality. And that is the end of your notes. And again, these are for you to be doing. And I cannot repeat this enough. You need to spend time understanding this. You need to spend some time on it. Logarithms are huge. They are huge. You need to understand them, and you need to spend some time trying to figure this stuff out. You get what you put in. If you don't put anything in, you ain't going to get anything out.